Hey, what's going on, guys? So we're continuing Chapter 9 for our final review, and we're on to the second part of Chapter 9, which is factoring trinomials. Alright, so we all know from last chapter that a trinomial is a polynomial with three parts. One, two, three parts. Okay? The easier way of factoring a trinomial is if the leading coefficient, aka the guy who leading the train, is just a 1. It's going to make our life a lot easier, okay? So just to get into it, I have this little example here that maybe makes it a little easier to see. Okay, so let's start here. We have x plus 2 times x plus 3. Now I know this is last chapter, but like I said in the previous video, factoring is basically the opposite of distributing. They kind of undo each other. So let's go top to bottom, okay? And I color coded it to maybe help you guys out. When we distribute, you have x times x, which is x squared. X times 3, 3x. 2 times x, 2x. 2 times 3 is 6. Okay. Then when we combine like terms, we get x squared plus 5x plus 6. Okay. So this would be our answer if we were distributing. But like I said, factoring is the opposite. It's undoing the distributing. So for a factoring problem, you would be given this as your starting problem. And I would say factor it, and you'd have to end up here. Let's just take a second and look at all these parts together, though. Let's look at our last term, the 6. How did we get 6? If we go back to the beginning, let's look at the blue line. 2 times 3, which are both of the second terms in this set of parentheses. Gave us the 6. Then how do we get the 5x? Well, we added 3x and 2x, which coincidentally, again, is the sum of the second term and the second term. Okay? And the way we got the x squared was just x times x. And as long as the coefficient here is a 1, your life's going to be simple. Okay? So let's go to this problem. All right? So I already did this one, but I shouldn't have. So let's look. We're going to have x squared plus 4x plus 4. Okay, we need to factor it. So, like on the last problem, we need to find two numbers that are going to multiply to the last that are going to add to the middle. 2 and 2 give us 4. 2 and 2 give us 4. Since the leading coefficient's a 1, it's just going to be x and x. And it's going to be plus 2, plus 2. Okay? And that's your factored answer. It really is nothing too crazy, nothing too difficult. Okay? So, here's another example. We have x squared minus 5x plus 6. Okay? So again, if you look here, we can't factor any GCF out. And the leading coefficient is a 1. So right off the bat, we know this will be an easy problem. So first we need to find numbers that multiply to 6. So we have 6 and 1, 2 and 3. Okay? We need to have those numbers equal 5. Now the trick here is we need to find two numbers, either 6 and 1 or 2 and 3, that is going to give us a 5. Okay? But it has to be a negative 5. So some of you guys might say 6 and 1. Okay, and yeah, that does make sense. 6 and 1. And in order to give us a negative 5, it must be a negative 6. But do both of these equations work out? 6 times negative 6 times a positive 1 is negative 6. We need it to be a positive 6. So right off the bat, you know, negative 6 and negative 1 aren't going to work. So then some of you guys might say, hey, if you make them both negative, that'll, well, give you a positive 6. But again, if we add them, negative 6 plus a negative 1 is not negative 5. So obviously 6 and 1 aren't going to work. So our only other options are 2 and 3. Okay? So the only way for 2 and 3 to give us 5 is if they're the same sign. But we need them to give us a negative 5. So let's just make everything negative. And let's check. Negative 2 times negative 3, positive 6. Good. Negative 2 plus a negative 3, negative 5. Good. So our answer is x minus 2, x minus 3. And that's all she wrote. All right, again, it's pretty simple. Let's go to the abnormal case. X squared plus 3x plus, I don't know, 16. Okay? Again, no GCF to factor out. Leading coefficient is 1. So we need two numbers that equal 16 multiplied together, they give us 16. Two numbers that add to 3. So we have 16 and 1, 4 and 4, 2 and 8. Okay? 16 and 1. Can they give us a 3? No. Because 16 plus 1 is 17. 16 minus 1 is 15. 4 and 4. They'll give us 16. We multiply them, but added together, we're only going to get 0 or 8. Doesn't work. We need a 3. 8 and 2. We multiply them, they give us 16. But when we add them, we're going to get 10. Or if we subtract, we're going to get 6. Not a 3. So right off the bat, none of our combinations work. So this one is prime. There's no way to factor it using our methods. You have to use a quadratic formula, complete the square, a whole bunch of fun stuff, which you aren't going to learn until Algebra 2. So just for your sake, it is prime. Okay? Because we can't find a factor of 16 that adds to 3. And that one's prime. Alright? Let's try this. X squared minus 2x plus, actually no, I want to make it a minus 2x minus 24. Okay? So again, we can't factor anything out, no GCF, leading coefficient's 1. So what times what equals negative 24? And what plus what equals negative 2? Factors of 24. 24 and 1. 6 and 4. 24 and 1. Try that again. 6 and 4. 8 and 2. Nope, that's a lie. 8 and 4. 12 and 2. Those are all the factors. Okay? So, we need to find which one of these pairings will give us a 2. 24 plus 1, 25, doesn't work. 24 minus 1, 23, doesn't work. 12 plus 2 is 14, doesn't work. 12 minus 2, 10, doesn't work. 8 plus 2 is 10, doesn't work. 8 minus 2 is 6, doesn't work. And obviously the one that's right I say for last. 6 plus 4 is 10, doesn't work. But 6 minus 4 will give us a 2. So we know it's 6 and 4. Which one's going to be negative? Well, since 6 is the bigger number and our answer is negative, that's obviously the negative one. Negative 6 times 4 is negative 24. Negative 6 plus 4 is a negative 2. So it's x minus 6, x plus 4. And that's that. And that's the final answer. Alright guys, so this is basically factoring a trinomial where you can't factor out a GCF and your coefficient, or your leading coefficient is 1. Again, it's pretty easy to factor them, and like the last example, if you can't find a number that multiplies to the last, you can't find factors that multiply to the last number and add to the middle, it is prime. So stay tuned for the next video and enjoy your day. It's nice out.